All right, so we know that for triangles to be congruent, all of their sides and all of their angles have to match. But you actually aren't required to know all of that information to be certain that triangles are congruent. So we have two postulates today, meaning that they are facts that are just accepted to be true because they're just true. And one thing is, if all of these sides match on a triangle, then the triangles are congruent. Okay. And notice I am having special care to make sure that, like, for example, the first two match like that, and BC and EF match, A and D match. Okay, there is a particular order. So if all the sides match, the triangles are congruent, and if you have a side, an angle, and a side in unison like that, like an order, then the triangles are congruent as well. Okay. Again, these are postulates. These are just kind of statements that just are true. There's really no way to prove these other than just to observe it. So here we want to prove that the two triangles here, this one and this one, are congruent. So we're given it's a rectangle, which we haven't studied what a rectangle is yet, but we do know that rectangles have congruent opposite sides. So what that means is AB is congruent to CD, and AD is congruent to CB. Basically, this side and this side are the same, and this side and this side are the same. We know that to be true of rectangles. And we also know that rectangles have congruent angles. All their angles are right angles. So we know that these two match. Okay, so all this really means then, so let's actually show the progression of what we came up with. So we first matched the sides, and then we saw the angles. And now we are seeing side, angle, side, side, angle, side. Like that. You see how we have side, angle, side right in order like that on both? That means that these triangles here are congruent, not because we matched all three like we did in 4.1. All we need is just to match a side, an angle, and a side, where the angle's between the two sides. So that brings up a vocab word, and that's an included angle and an included side. So basically, included means between. So for example, like angle A is included between, how about like AB and AC? So it's like between those two, you see? And that's what's required of SAS. Okay. And an included side is, again, just between two angles. So we could say BC is included between angle B and angle C. This side right here is included between this and this. So we'll use that word included. It just means between. Here we go. Are the following triangles congruent, or is there not enough info? If so, like, what shortcut should we use? So this first one, we do know that these are congruent, and that opens up the door to SAS. Over here, we don't have a lot, but we do have ASS, or also known as SSA. And luckily, this is not one of the congruence theorems. This does not guarantee the triangles are congruent. And with a bad word like that, that's convenient, so I don't have to continue writing that. So this is not one of our congruence theorems. This one is, though, because they have a shared side, so it's equal to itself, and we have SSS. Okay. Let's look down here. No shared sides. We do have an angle and a side, but not enough info. Okay. Let's see. Here we're just simply told that all the three sides match. So this would be yes. And this one over here is no. AAA is not for congruence. We will study AAA a little later when we do similar triangles. These are similar. Not congruent, though. Okay. Let's see. We got given, and we have our triangles that we are trying to show are congruent. So now that we have these shortcuts, typically this should be either SSS or SAS. So we are told that JL is a bisector for this angle right here. And we're told that these are congruent. Okay? So we definitely want to use the definition of bisect first to get any information we can from that word. And if this JL did cut the angle, that would mean that these two match. Okay? So that would be angles KLJ and MLJ. So we have an angle. We got an angle and we have some sides. Let's see. Anything else that could be equal? With an angle on the side, we're hoping for another side. And we don't know anything about JK, but we do know that this JL is congruent to itself by the reflexive property. So by having that in writing, it's showing us that we do indeed have SAS on both. And notice how the angle is included between the two sides. It must be that case. So this is SAS. Okay. I'm drawing these extra ones to, if you want to like help and draw. I'll do a better job on the next one showing you what you can do with those. So, given, what are we trying to prove? That triangles are congruent. So we are on the lookout for, at this point, SSS or SAS. So that's probably going to be these reasons here, is either a side matching or an angle matching. We are given parallel. Okay. We also are given that those are the same. And we're given that we have a midpoint just between this. So we have a lot to work with. I would start with the definition of midpoint, although you can start somewhere else. And I would say that QR is congruent to SR because that's what the midpoint did. So what you could say as you're discovering things is you can update the picture separately so you can keep track of like what you knew before and what you know now. Let's see. So maybe we're close to side, but I don't see us having any info about PR. So maybe it's an angle. We haven't used the fact that they're parallel yet, so it's probably an angle. Um, this can be a little bit tricky. We have two transversals. We have one that's P and T. So these angles should be the same. But notice how that gives us ASS, which is not a congruence theorem. So even though those are the same, I'm actually more interested on what happens when we draw QS, right? And I think that these would be congruent as well because those are alternate interior angles. That would be angle Q and S. So these, so again, just, you don't have to be organized with your pictures. They're just there to help you. Those are, because it does make that Z shape that we've been looking for. Those angles are congruent. They're alternate interiors. Okay. And what do we have? Well, we have the red angle right here. We have these are the same. And by the midpoint thing, these are the same. So again, we do have SAS. Okay? So we haven't seen a proof with SSS, but I would take a look at the homework and maybe you can see one there.